Hello everybody. So thanks for being here. I know for some people it's not the most ideal location. For the other ones it's perfect, like the ones of West Flanders. I'll try to not speak too much Flingels because we know how that goes. So just a small introduction with Codit. We do nothing but integration, and it's always using Microsoft technology. So in the past that has always been BizTalk. But more recently, we started with Windows Azure. And we did that by creating a platform called the Integration Cloud. So it's fully built on the cloud technology with Azure. So the PaaS, so cloud services, Service Bus, Windows Azure BizTalk Services, and blob storage and all of that. So just a very high-level introduction to show what we are doing, and because it all links to the current session. So what we are using with our integration cloud solution, it's a runtime. We have an integration worker, so that's a cloud service, and there we have workflow. We have persistence to blob storage. We use SQL Azure for all the tracking and configuration, and of course we have Service Bus, and I'll be talking on quite some things on Service Bus today because we use it for all the messaging, the routing, and things like that. And more recently, we started also with BizTalk Server and Services, so the new service that I'll be talking about in the second part of this talk. We also use a lot of connectivity that I'll be showing today too, so connecting from the cloud. So the integration platform is in the cloud, but a lot of customers have their local systems in their own data centers, and there we use the adapter service that I'll be showing. And we also have a cloud connector. That's a custom-built thing using Service Bus Relay. So I'll be talking about these things, not about the platform, but about the components that we use and the concepts that we use today. So it's actually built in two different parts. So the invitation was for Windows Azure BizTalk Services, but I'll start by talking a little bit on cloud integration patterns itself. So the different technologies that you have in BizTalk, in Windows Azure for integration. I'll be showing them mostly with demos and some best practices. And the second part will then be a deeper dive or a round trip through Windows Azure BizTalk Services. So with integration, I've been doing integration since 2000, and I know a lot of you have been doing it, but I know that some people are not too familiar with all these concepts yet. But what we have been doing in the past years was always connecting systems inside the same data centers with each other, so connecting the SAP with the CRM system and so on. But what we saw is that systems were moving out to the cloud more recently. So CRM is now suddenly Salesforce.com running in the cloud, or CRM Online, or the HRM system or department is coming and, oh, we have a new nice application for you, and by the way, it's running in the cloud. So that's the whole SaaS thing. And still we need integration with that. So still the SAP or the mainframe running here to be had to feed these systems. And that brings new challenges. And I'll be talking a little bit about those challenges and more specifically on how you can solve them with the new technologies. Of course, mobile applications, it's becoming, it's booming. And mobile applications is not just about building that shell, that Windows 8 or that iOS app. No, it's also about providing your data, your services from the inside systems to those mobile applications. And then the partners, so we have a lot of customers where we have connectivity between the customer as the supplier and their customers, or the other way around. So they order items and they send invoices and things like that, and all of that is going automatically for a lot of these larger customers, and that's the B2B part that I'll be talking about. So different challenges that we see with cloud integration that were not necessarily there in the past. It's typically, security is a big one, so the identity. In the past, we had a trusted subsystem locally, and we had everyone connected with each other, and as soon as you were authenticated by that local bus, the bus could do whatever they wanted. But now, suddenly, you have users connecting through mobile applications where you need to have the identity, and they suddenly need to reach your mainframe or your SAP systems. And those are things that you really need to take care of, that you're exposing things to the outside that were not exposed in the past. and that means that you have to think about security differently. So that's the mobility and the identity. Of course, connectivity in general. Not every network, not every application is ready to be reached from the cloud. Microsoft has technologies, but not every enterprise organization is willing to change or to adapt to those new patterns. So that's also a big challenge nowadays. And of course, the thing it's all about REST now, especially with mobile and cloud. And a lot of customers have still their flat files, their SOAP services. So not everyone is internally REST ready, let's say. Another one is, of course, crucial is the latency, the network latency. So if you have your integration or your things in the cloud, you have a considerable longer latency compared to your intramuros connectivity. So you need to think about that when you set up these things. So the different technologies that we see inside the Azure platform, and most of you will be familiar with it, is the application integration, of course, and that's Service Bus with, let's say, 3 different components that I'll be talking about. BizTalk Services, and I'll keep that for the second part. Then we have data integration, identity integration, and the network integration, which I'll be showing in the end of this first talk. So the first one is Service Bus. So who has been playing with Service Bus already? Okay. So you have 3 things. You have relay, you have messaging, and you have notification hubs. The first one that I'll be talking about is the relay, and I'll be showing a demo on how we use it. So what you have, it's typically a web service locally somewhere, or it doesn't have to be local, but it's very handy if you use it locally, that you can expose on a relay endpoint that is running in Windows Azure. So that means that someone else can connect to that public endpoint, and the relay service will forward that request to your local service. That local service can be running behind different nets and firewalls and all of these things. And you only need to have outbound connections. So what happens if you start up your service host? Think about WCF, you start it up, you register itself on a service bus, and there we have a namespace. So you create a namespace, and that's your unique own URI inside the Windows Azure platform. And in that namespace, you can create your own hierarchy. So you can say, okay, I have the first part, for example, for my sales, then I have a production, and so on. And you can build your own hierarchy, and you can give security rights on that hierarchy. So whenever you're registered here, you say, okay, now I want to be registered at azure.servicebus.windows.net/my-local-system. Anyone who can access that service using different security things like certificates, the secret keys and so on from ACS, can have access to your service here. How does that go? First of all, the sender sends its request to that public endpoint, and that's really sending it to the cloud, to the Azure Service Bus relay. And there what they do, they create like a socket forwarder, and you have the receiver listening on some kind of bidirectional socket, and the message itself, the request, is sent in the response to the initiated request. The request coming in is sent to the local receiver. As a console message, he gets the request, he does his logic, and he sends back the acknowledgement or the response message to the sender, to the original caller. What's very important here is that the initiation of the connections are always outbound for this receiver. So the only inbound thing is in the response of the initial request, and that's allowed with firewalls. You can go outside and you get the request back in. So that's the same thing here, and it's a similar pattern as you have with Skype, with SignalR, with WebSockets, and it depends on the topology that they will choose the right logic. No, it's underlying on the network thing, and if you want to know the real details, You know, it's Clement Vasters that is really capable of explaining all of that. It's not a long polling thing. It's comparable with, I believe, SignalR technology. Maybe you guys know more of that. But it's comparable with that, where you have, based on the topology, you can have TCP, or you can have TCP, HTTP, and on that, it will pick the right, the best suited technology or pattern. Okay? So, as a first demo, what I'll be showing is something that we use at customers where they have, so we have the cloud integration platform there, and locally they have a cloud connector. So that's a very lightweight service that we install in their data centers. So it's not a big BizTalk, it's not something that has SQL backends, it's very lightweight and it's included as a service with the platform. And we can manage it and we can send messages to it. So this is running behind firewalls, but still we can reach it from the cloud. And that's using the service bus relay. So how does that go? We just need to connect to our portal. So this is the portal of our integration platform. And there we can connect to a specific runtime, so a tenant if you want. And in the configuration, I will be able to connect to a specific cloud connector. So whenever this starts up, what he will do now, he has a list, and maybe I should zoom a little bit. He has a list of the different connectors that are configured for me. So I'm not talking about the whole way we connect that, but we have 3 connectors. What is that? It's 3 services running in different data centers. And I'm able here to manage from our cloud portal one of them. So the first one here, AX connector. Whenever I connect to it, now actually he did a call to that service locally, and he sends back, look, this is my configuration, and by the way, this is my logging. So I can now, for example, say, in the details, I can go and configure things. I can change and say, instead of polling locally on that server on F, blah, 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 you need to poll on a different location and things like that. So I don't have to go on that local server to change configuration settings. No, the service has a management service like an API, and we call it from the cloud. And the way we call it is really using the service bus relay. So that's the concept where we can easily update things. We can set different connections, different properties. So what we do here, we say to that local service, if you receive a file here, you need to send it to this endpoint. And again, here, this endpoint, AX invoices, that's again an endpoint exposed on the service bus. So we will send with the security key here that you can see, we will send to the cloud, and there the management or the connectivity will start. Does that make sense so far? So it's really calling local services, even if that is running behind the firewall and things like that. Okay? So some best practices where you can really use relay in a nice way is the fact that you can have load balancing out of the box. So imagine that you have a very, let's say, stateless service that can, for example, sign PDFs. That's one that I sometimes use. You sign PDFs. You get a requested PDF in, you sign it with a specific certificate, and you give the signed PDF back. And you want to have, let's say, a high available thing, or you want to easily scale. What you can do is you can run one locally in your data center, you can run one in the cloud, you can run one at Amazon, all using the same public endpoint. And if someone calls, if Azure is down, no problem, it will be routed to one of the other 2. If your local data center is down, no problem, Amazon and Azure will be running together. So it's really distributed, it's distributing the load in a round robin thing to the same endpoint. But of course, if one of the endpoints is down, the service bus knows it and he will redirect requests to the remaining 2. So that's a nice thing where you can have some disaster recovery things. Also between data centers, these things can be done. One that we also use every now and then is the routing service. So if you know the Wcf routing service, it's a way where you can send like one generic input message, and based on the SOAP action, based on XPaths, based on a lot of configurable things, you will route it to the right backend service. So it's like a lightweight proxy in between other services. What we do, we create one public endpoint with the service bus relay, and behind that we have the routing service. So that one is then routing to maybe 15 backend services. Why do we do it? It's a lot cheaper. Instead of having 15 endpoints, one for the order service, one for the invoice service, and so on, we only have one relay endpoint, so 1 hour that we pay instead of 15. And it's shielded, so behind the scenes we route it to the right services. Okay? So that's a tip to save some money if you want. Then on the security thing, so you have shared secret, you have the ACS tokens, you have ADFS tokens that you can use. And what's very important, and not everyone knows that, is there's a nice tool, the Service Bus AZ, so the Authorization Manager. It's a tool that you can just run, and you can configure, like you can create users. So probably in all my demos you will see the owner as a user, because lazy and I didn't have too much time to prepare. But in production, like with the Cloud Connector, we will never use owner in local data systems. Why? Because if someone has the owner plus the key, you can delete topics, you're king in the namespace. So what you do with Service Bus AZ, you can say, oh, I create a user that is just able to listen on an endpoint or send messages to this queue and so on. So you give them specific rights on a part of your namespace. So that's a very important one that you should think about. And then this is just for your reference because the slides will be shared anyway. It's a blog of Clemens Fasters again, where he writes about a common thing in a lot of enterprise companies, where they say, okay, if you want to send to a public service, we need to know the IP address of that public service. And they say, okay, you need to, this server has to have access to this range of IP addresses. Here he clearly describes why it shouldn't be like that anymore, but unfortunately, it's not always that easy to change enterprises. One of the reasons is because the IP addresses of Service Bus and Azure itself, they change. New data centers come up, new servers are being added, and so on. So that's something that's sometimes painful, where traditional enterprise companies still want to block outbound connections, and you can end up with some issues there. This is just for your information. The ports that you need to open, outbound only. If you want to have TCP, these are the ports that you can do. You can also have HTTP outbound, and that's standard ports. And also for the HTTPS thing. What's important is that you have this one here, direct connect. This and the server, the client and the service are able to have a better connection, a faster connection. Like if I would be running here and my server's there and we are on the same network, it actually doesn't make sense to go through the Windows Azure data centers all the time. What happens if you open these ports, the 9353, they will do some rendezvousing or chatting with each other and try to have a direct connection. And you can see it with the duration of your calls. Whenever the direct connection is made, things go much faster. You have a much lower latency. So that's a nice thing where they switch from relayed connectivity to a direct connectivity. Okay? Yeah.
And do we still need to pay for traffic?
Good question. I'll take it offline. Okay. Yeah. Unless someone knows. I think you don't have to pay because probably they don't even have the traffic, but it's to be to be checked out. Okay? Any other questions on the relay? Nope. Then we have the second thing, it's messaging. Someone has used MSMQ, JMS, MQ series, things like that. If you have done, this is a lot of similar concepts there. So it's all about queuing durable messaging. The good thing is that instead of MSMQ, where you just had some .NET classes, it's more interoperable, so you can send to queues and topics and so on using REST. So that's from virtually any platform, including things like the Gadgeteer and the NetMF that we have seen in Cloud Brew. AMQP is a newer standard that I think almost every big vendor except IBM is betting on. And then you have still WCF and .NET if you want to have your native existing experience. So what's going on? Here I talk about topics, but a queue is a queue that everyone knows. You put a message on it, and you can have one or more receivers listening on those messages, right? But with topics, you have something like a PubSub, and if you know BizTalk Server, it should be, it should ring a bell. So what is that? You can create subscriptions. So you can put one message in the topic, and you give it metadata. It's like properties, and you can have one or more subscriptions using filters. It's like SQL 92 syntax that you can create. So you can say all the orders of France should end up in this subscription. You can have an audit subscription where you say, I want to have every incoming message on this single subscription. That's, for example, setting 1 equals 1. That's a typical rule that you can use. So you can have one message going in the topic and multiple different subscriptions. And then receivers read or listen on subscriptions. So what's important here, you can only write to a topic and not read from it, and you can only read from a subscription and not write to it. So they are always linked with each other, topics with multiple, with 0 or more subscriptions. Okay? The next thing will be a demo, and I'll be doing that maybe now. And now my geeky thing starts. So some of you have wondered what this is. So this is a receiver. It's like a radio antenna, and it receives signals, like radio signals, but they listen on a specific frequency. And actually, it's the one that is receiving data from airplanes. So planes are flying over, and people might know, I don't know if it's open, this application here, Flight Radar. If you don't know, it's very nice to, like if you sit in the garden, just watch what's going on. So you see these messages are, these planes are in the neighborhood here. So this one, for example, and it's flying from Malaga to Copenhagen. And this one is going also, he will fly above us. It's Ryanair, be aware. So it's from Marseille to Eindhoven. So this is real live data. So if you would look outside, so we are here somewhere, he will just fly there somewhere, right? The nice thing is that entire network has been is being fed through clients like this one. You have much bigger professional ones, but this is a cheap thing that I bought for I think 25 euros. And you can just connect it to USB and you can receive with it. So it's a nice demo to play with. And you get this thing here is an open source application, virtual radar service. And you can add plugins to that. So what I did, I created a plugin, Service Bus plugin. And you can see that I have sent 444, and you see messages are being added. I have sent these messages because these are messages that I have been received, that I received from the airplanes. Those messages are not containing that much. They say typically, I'm this plane. And sometimes, depending on the type of message, you can get the latitude and longitude. So to get a position, you get the speed, the altitude, and you can look up the flights, for example. You can see, oh, he's going from there. So all the rich logic that you have seen in the flight radar, you can access that. So the only thing that I did was I want to get all those messages and I want to publish them to Service Bus, to a topic. I didn't write any GUI because I'm not really good at that, but it's just a concept. If I would build Flight Radar, I would probably have a lot of input topics where people can feed their data, and then you can process them with all the power you want to have in the cloud. But the logic here, maybe I should first go to the to the service bus portal. So what I have done, I have created a topic, radar02, and on that topic, I have created one or more subscriptions. In this case, I just have the audit subscription. And in the audit subscription, you can set some parameters. So you can say, how long should the, oh no, that's on the topic. How long does the message has to be a default time to live? So if a message expires, the time to live expires before it got read from the queue, the message will be deleted and so on. You can set a lock. So if you have multiple receivers listening on those subscriptions, you can lock a message, right? You can do your work so no one else of the other receivers will get to that message. But if you blow up for whatever the reason, the lock will be released automatically after this interval. So you have a lot of tweakings you can do. Also for performance reason, you can batch things together, you can prefetch, so you have a lot of settings there. Another tool that I frequently use is this one, the Service Bus Explorer by Paolo Salvatori. So he's still a BizTalk guy, but he's doing a lot of these things. So if I now move to my flight radar, I should be able to read on this subscription. You can see here the rule is just 1 equals 1. If I now do a peek, where is it? Peek messages. I now get a top 10 messages, and you see this is the actual payload that we get. So this is like a flat file string getting some data. This is the most important number here. That's the real ID of a plane. The 111s, those are like default values. And here, what I also did, I created some metadata properties. So in this thing here, the custom properties, you can see the 111, it's like the default, but the ICAO thing, that's the unique key. So these are the properties that I have specified. We want to create a subscription on all, like I want to have a notification if something is alerted with this specific plane. I could create a subscription on that, and you know, messages would be routed to there. What you can also see is that I have actually 446 messages for only 7 planes. Why? Because a message or a plane is broadcasting signals, and yeah, they are in my reach for a longer period. So only 7 planes generate 400 and more messages. But what I do, I use a feature of Service Bus here, and you should see that with the configuration. I use the duplicate detection thing. So for minutes, the service bus will make sure that that if messages with the same message ID are sent to this topic, that he will only take the first one. So any subsequent message with the same message ID will be blocked. So that's why in the topic, I only would have 7 messages instead of the 400 and so many messages that I have sent. Okay, because I have a message ID with that specific code. So if you now go to see some code, I actually used REST instead of the .NET client, because this is still a .NET 2.0 application, and changing it to 4.5 resulted in some issues. So I said, let's go for REST, because there's no SDK for, let's say, 3.5 and below for .NET for Service Bus. That's an important one to know. But what I did, it's mainly here. So I listen for such a specific message, and then I say service bus transmitter.send. So if we go to that logic, what I do, first of all, I create my service address, and what is it? It's my service bus namespace, and I need to send to the topic /messages to that specific topic, right? So that's the address. I will be doing a post, and then I do yeah, I have to create my ACS token. So I use the owner thing for this demo. That ACS token is something that I cache. So if you would go and have a look, you will see it's a static thing. So I cache it for, I think, 20 minutes or something. Why? Because that is always an outbound call, and the token is valid for a configurable time. So you don't want to have that call, that overhead every time. So I just cache it here. And I add it to the authorization header. Here I specify some specific properties on my message. So these properties are system properties that will be used with Service Bus. And in this case, it's just a message ID. So that ICAO thing, that's the unique code for the aircraft. That's what I use as a message ID. So if that aircraft has sent 10 messages, it will be 10 times the same message ID. Because of the deduplication, only one message will end up in the subscriptions. Then I add some headers to the client. So these are just the custom properties. So if, for example, it's an emergency, I could send a specific subscription that says, okay, the emergency, and I could have separate applications pulling on that. They probably use other technologies for that, but anyway. And in the end, what I do a post to that specific endpoint, and I give the base string that you have seen, the flat file, to that in the body of the message. Okay? So messages arrive here, my topics, and in my subscriptions. Does that make sense so far? And now I could start polling on them. I could process them. If my worker role, like in this case, is down, the messages are still being queued, and I can process them for later. Okay? You need to think about that. Maybe this message is no longer relevant because the time might have been expired, or you can say, no, here I'm processing all the data to do business intelligence and so on, and to store everything in table storage, then it can still be valid. So that's up to you. Okay? That was Service Bus messaging. Some notes on that. Yeah, of course, transient fault, it's a concept that you see coming back every time in Azure. So if you go to SQL Azure, if you go to Blob, if you go to ACS, it always can happen that for that 1 millisecond you do that call, that service is not responding. So you need to catch those exceptions, and you need to take care of that. So the good thing is that with the Q client, and that's I believe since 2.1 or something, the Azure SDK, you have out-of-the-box retry policy. So you can say Q-client.retry policy is exponential, so that he retries fast in the beginning but backs off over time. You can say don't do retry and so on. And now that's all included. So you don't need to do the catch and the retry or use the patterns and practices things there. And another one is the receive mode. So peak lock, that's the one that is most, let's say, reliable, and that's the one that I talked about with the log duration. So if you listen on a message, you can say, I use peak lock, and what does that mean? You log the message, you do your work, and whenever you're successful, you complete it, and then the message is really removed. If you log the message and your thread crashes for whatever the reason, the message will be re-released to the receiver at the end of that log duration. So that's, let's say, the most safe thing. But of course, it takes a little bit more performance overhead. So you have to estimate what you do best. Because in some cases, it can be enough that you say receive and delete. I receive the message. If I fail, no problem. It's just one message out of millions that it won't matter, for example. Receive and delete can be more than enough. Some things you can look into. So prefetch count, batched operations, they will care for a better throughput. So if you have high volume, constant high throughput, these things can be played with. I just put it here for reference. You can easily find documentation online. You can also have multiple clients, of course, listening and concurrent calls. I will show that. So that's just a property with a new thing. You have message pumps with that same concept. You can say, okay, I want to have 10 threads, and that component is spinning up 10 threads. But that's for the next step there. Empty messages is something that we often use, where we say we don't send the body with the message. So now you have seen that I have sent that flat file body. You don't have to. You can just send an empty body and just use the properties. The good thing is that you don't have the serialization from an object to that body, or your body to the object. And you can just work with the collection of the properties. For signal messages and so on, that can be more than enough. Also, large messages, there's a limit. I think still 200 or 512. I think 256K for messages on Service Bus. Of course, you sometimes need to send larger messages. So what you can do for that, either you store the message on blob and you send the reference or a shared access signature with your payload in the body of your Service Bus message, or you can use sessions. With sessions, you can say, okay, I chop my message, my full fragments of 250K, and you send them in one session. And with that session, you are guaranteed that the receiver, even if there's 10 receivers on the other side listening for your message on that queue, if you send it in a session, the receiver that has started receiving on a specific session, he will get all the fragments for that one specific session. So it's not that I'm listening together with another receiver and message 1 and 2 will go to me and message 3 and 4 to him, because you could not, let's say, recollect the message in memory there. So that's something that you can use based on your scenarios. Okay? So that's what we have seen, where you can have one or more radar like these feeding into the same topic in the cloud. You can have then multiple subscription. An example, the emergency subscription, where he filters for all the messages of type emergency, and you can have the PON. I hope there's not too much throughput on those ones. And all could be an audit, so 1 equals 1. And you could say, okay, I want to have all data from planes that are Boeings. So just whatever you think about, you can create subscriptions as long as the data is here in the properties of that message. So if you have a Boeing going into emergency, one message will go in and you will have 3 messages on the subscriptions. And that could be that one role is processing the emergency ones, another one is doing the logging, and another one is doing the Boeing analysis, whatever. Okay? The next one that I will be talking about, and that's the third part of Service Bus, is the notification hubs. So if you want to create push notifications to Apple, Android, Windows 8, or Windows Phone, this is a very nice concept where you can just push millions of notifications to that hub, and Windows Azure, that service will take care of pushing the notifications to the systems. So I don't have to know anything about iOS and Android and so on. I just have to know the specific registrations that they use. For example, with Windows 8, I'm not an expert at all there, but you have in the store, you have some push notification settings like a big key and so on. You need to enter them, and then everyone who has those shared accesses actually can start listening there. So you can build applications and receive signals from that. So that's the next part of my demo. Going further on these topics, I've created a worker role that is listening on the all. So he's listening and polling for those messages. And for every message, he will send a notification hub, a notification message to my local application. So how do I do that in code? I've done it here. So this is the worker role where I'm reading from the subscription. And it's pretty dirty. You see my key here. And the only thing I do, I create a namespace manager, and then I say, create my queue client. So I create from the connection string my subscription, or my client, and I'll be listening on this topic and that subscription, okay? And then in the start, in the run method, the only thing I do here is with that client, I say, and that's the event paradigm that was added in, I think, 2.0. If you say on message, you have to execute this piece of logic. So what I do, and I can have a lot of other things. For example, I can set the client retry policy, as I just mentioned. Something like this, no retry, and so on. You can have other things like client.threads. is it? No, it's another one. I'll skip that one. Anyway, so whenever the client is receiving a message, this will be handled. So what I do, I read the key, so that's specific aircraft token again. And if the aircraft itself was filled, I override it. And then I do a notify announce, and that's the notification hubs thing. So if I go to my Windows Azure portal, there I should be able to see notification hubs, and that's another namespace, it's here. So here I have a notification hub, and I used it for another project where you can pull on Stack Overflow, for example. And you can configure things like, and these are the Windows notification settings. So this is the client secret that you have to know, and so on. So those are the ones that you can get from the store. You have other things for Windows Phone. You have certificates for Apple and things for Android. So you have, it's just a matter of getting the right values from those specific services, and you need to configure them here. And then you have these things, shared keys that you can use in your client applications. So this is what you need to know in your client application. All the rest itself is managed here. So what I do, this is the server again. I create a new hub on the same, on the service bus namespace, and then I say, okay, send a notification, and I use templates here. You will see the details in the client. I just sent actually name value pairs. So what I do, a dictionary of string, and I say the message, watch out, flight X is flying over your heads. ID, this is the aircraft. A URI, if you would click it, you would go to the flight radar to follow it, for example. And I give the flight as tags, because tags is something that you can subscribe locally. If I would say Boeing, for example, and you would only sit in Boeing, I would have all the notifications going outbound, but maybe you're only interested in the Boeing ones, and you can configure it in your application, and you would only get the Boeing ones, while your neighbor might get all the Airbus ones, for example. So tags are also pops up again that you could use locally to subscribe on the events you want. Think about other things. I want to get all the weather updates from Ghent region. I can just subscribe to Ghent. Even if the cloud service is sending all the weather information over that notification hub, I'm just interested as the client in Ghent. So I can only subscribe to those specific tagged events. That's the concept here with tags. That's about it on the server. So whenever I start this worker role, I will run it locally. He will read from the subscription, and we've seen that there are some messages sent the data through these notification hubs. Then I also have the client application, a Windows 8 application. Don't expect anything fancy. The only thing I do is just an initialize thing here. So this is the client side where I'm creating a Windows 8 application listening for events. So again, I register this hub, this notification hub that I just used from the server. And I use a shared secret thing here. And then I say, okay, use a template. And you have inside Windows 8 different templates. For example, this is the template that will be used in my application. So here I say it should be a toast and image. So I will get an image pop-up and a text. See that in a minute, where I can replace things. So here I can say, actually, I can replace values with the tags that I get. So the name value pairs like flight, I can replace them easily. Like here, select the first text and say, okay, the inner text should be the value of the message that came with the notification from the notification hubs. Same thing, the ID, I will update it with an image that is running locally. So let me just start and it will become much clearer. So I'm now running my service locally. Of course, in reality, that would run in a cloud maybe on 10 servers. And there they are. So you can already see these flights have been notified. I'm in the code here on the server. So where I can just step through. So I have received a message. I can say, okay, this is the key, this is the aircraft, and so on. Let's go to the notification here. Where again I can say, oh, this is the flight, this is the aircraft, and whenever I do an F10, I should see next time, there it is, the notification coming in. This is just one application. Imagine that this is the football application in the World Cup using notifications. You're sitting at your desks working, and you get all those those notifications, but maybe just the ones that you are interested with. Maybe they will send notifications for every time someone, maybe every goal, maybe every corner, whatever. You just subscribe in your local application. I'm interested in all the corners of the Red Devils, for example. You get that specific notification. So it's really the cloud is doing all that specific logic there. So deleting all the breakpoints, and I get all the messages here. So here I combine service bus messaging with service bus notification hubs. Okay. Now I'll leave this running. So anytime a flight would come into the picture, we will get a new notification there. Any questions on service bus in general? Nope. Good. So some, quick notes on the notification hubs. It's cross-platform locally, using the different notification systems, because Google is different from iOS, is different from Windows. Templates are really nice, so you can send just the name value pairs, the real data that is interesting. And in your client application, I decided now to use an image in combination with a text. If someone else wants to use something different, they just apply the name value pairs to their UI. This is not possible. I talked about that with the service bus team, where I was hoping to have a forward to. So forward to is a concept also available in service bus messaging, where you can say if a message arrives on this queue, forward it automatically to this subscription or to this topic, for example, to another queue in a transaction. So I was hoping to have a forward to a notification hub, so that I don't have to write any roles like I'm doing now, that it would just be forwarded. But it's on the longer term roadmap or message handler. You can do PubSub, like I said. So if you want to pick your specific team, you just do a subscribe, but from your client, and that's a very nice thing there. And not only on one tag, you can have a list of tags, right? It doesn't have to be one specific there. Okay? One that I will be going very quickly, because maybe you guys know more, but it doesn't seem to evolve, and it's still in preview. It's SQL Azure Data Sync, but it's a pattern that is sometimes used, so where you synchronize data from locally in more of a batch manner to your cloud database. Azure Data Sync is one, but you could just use SQL Server Integration Services, SSIS, and you have a lot of third-party products doing that, where you schedule things like, our data has changed, I will now synchronize my cloud database. Examples can be where you need to look up data in the cloud, and you don't want to go for every call to your local server. No, you just say, my customer table, I will synchronize it to the cloud every now and then. So for some kind of caching, actually. So you have concepts there of lock resolution, where you say, the cloud database always wins, so if data has been updated, the same record has been updated in both databases, you can specify who wins, the local one or the cloud one. There's impact on database schemas if you use SQL Data Sync. So in your synchronized databases, this is all created for you. In separate schemas, so it's not in your existing ones, but they are all created like new tables, new triggers, and things like that. So it's important to know that. Role filtering was there, so you could say only the customers that are e-commerce enabled should be synchronized, so filtering on fields. Last time I checked, it's not configurable in the new portal, so in the past it was. And that's the biggest pain point with it so far. It's still a preview service, and it's been there from the beginning, and it's still in preview, so it's not, let's say, the one that I would recommend for real production scenarios now. Another one, but I'm not going into details here because last time Nuno was covering this, is Active Directory. So it's another kind of integration where you integrate identities. So you have the dsync, the directory sync tool that Nuno talked about. So where you have your local AD, you can synchronize users to your cloud Windows Azure Active Directory. You then have the single sign-on. So where you can, for example, say, okay, if a user is signed on with the local Active Directory ID, he gets automatically linked with the right role of Salesforce.com, all these things. Then you have, of course, ACS, if you were on Cloud Brew, it was a good session on that. So where you can use, for example, Active Directory as an identity provider using federation services. And then the one that was added, I think, 2 months ago or something, was the multi-factor authentication. So you probably have seen that. You go to a hotel somewhere in the outside of Belgium. You want to log on to your Outlook or whatever, and they say, "Oh, it seems that you tried to log on from a different place. Here, let's send a text message to your mobile. And you need to enter that." So that's the multi-factor thing, where you can have either phone call or SMSs to double check. That's important for a lot of enterprise companies, where if they want to use Active Directory in the cloud, that they at least have these guarantees that they can say, no, always phone authentication with it, and so on. Okay? Then the last, let's say, pattern is it's another geeky demo. It's network integration. So with network integration, there's things where you can set up some kind of VPN, and you have two ways. You have point-to-site and you have site-to-site. So point-to-site, that's really where you can have one client connected with a virtual network from a client perspective. So I don't know if I have it here. I think I removed them. But if I would have connections there, I would see an extra connection, for example, my Windows Azure connection, and I would be able to connect to that, meaning that my server now would be able to talk with the cloud service and the other way around. So they would be in the same virtual network. But site-to-site is different. That's really connecting a VPN tunnel between a device locally in your data center, or with Windows Server 2012 RRAS or something services. You can also set that up, let's say, software driven. It's a connectivity between your virtual network in the cloud and your local physical network. Yeah? And whenever I saw that coming up, I had some things, because at home I have this thing. It's a home automation system, so Domotics, and I have that since I think 3 or 4 years. And they have a TCP thing, so you can talk TCP with it, so you can automate, and that's what we love to do. But what I didn't want to have is, let's say, fixed servers in my house. Just, let's say, we need to go cloud, so only devices but no servers. So what I said, I want to have my server there, and I still want to connect to my local system here. There's a lot of different patterns you can use. Eve and Andy have been talking about that last weekend. But what I said, okay, let's do it, let's say, easy, because I had all the logic to connect over TCP/IP. I said, let's just set up a VPN between a cloud server and my local system. So going online, I said, oh, there's this the cheapest device that should be supported, and that was Cisco. So I bought that one, and then I had some long weekends with a lot of new things for me that were, if you're a dev guy, that's all new, but it was interesting. So what I did, I set up an IPsec tunnel between my cloud services and my local house. And then from there, calls would be relayed. So from my cloud role, I have just an MVC web API. And there I can just do something like TCP call to 192.168 and so on. And it would just it would be like this one would be running in the same network. That's what I set up. So let's go to a demo here. And if my wife is looking on the live stream, maybe you shouldn't be in the home office now. So let's see. So this is the basic thing, right? I just have an IP address connecting on that specific port, and I do my logic. So I have this API here. With a curtain controller and a light controller and so on. So where you can do up and down of curtains. So you can see that I have deployed this one at 3 this afternoon. And what do we do for REST testing? That's of course Fiddler. But of course you wouldn't believe me. So I hope Google Hangout is not recording my key entries. So what I have a local, like an IP camera. So I should be seeing here, the curtain is open, so this is at home, live. Let's move this one here. Let's go to my portal, where I should have my cloud service. So that's the API here. And you can see it's just running on one instance. It's not that I need a big scale for that one. And I will be connecting on RDP just to show that I can ping and so on. So I'm pinging there, and what you should also be seeing is the network here. So the network, as you can see, this is the gateway, and that's the thing that you really pay for, except for the bandwidth. So the gateway is something that gets activated, and as long as that is running, you pay for it, right? It has a public IP address, and then of course you have your local systems, like the Water Street network. That's my local network that I configure, and that has a public IP address. This is the one from Telenet, so that's my local router, and I need to configure that. Okay? You can see here that I'm able to ping, right? So I get a reply. I also secured my API with this key. Ah, shit. Anyway, the role will be taken offline and the new key will be generated. So, a put. So putting a curtain means doing the curtain down. A delete will be picking it up. So that's my interpretation there. So let's try to execute this one. Oh, 401. Ah, there's security. Let's try the one again. Oh, that wasn't the body. My API key should be a header. Okay. So I got a good response back, I think. Oh, there it is. So the camera itself was not too fast, but the curtain is closing. And if we now do a delete without the body, it should open again. And maybe we can see my neighbor then, although it's pretty dark outside now. So there it's going up again, right? And why not? let's do something with the lights. You don't see the light itself, but it might be a little. Oh, I did a delete. It should be a put. So the light normally is now turned on, but it's not very visible. So that's, let's say, a nice demo again to show some concepts where I just connected my local network with the cloud in the same thing. So I could ping, I could do everything I wanted to do, right? So let's close that one. Let's go here, because you don't believe me, right? Delete. Okay, so that was the virtual networking thing. So some notes again. So it's a secure, the VPN thing, it's a secure network tunnel, but it's probably not suited for mobile devices. If you go to the Internet of Things, VPN is probably not the thing you want to have. There's other protocols that are more suited. It's not necessarily to set up a VPN, because whenever you are, through the VPN, there's no security anymore. It's a unified network. So you have the configuration scripts in the portal. So I didn't show that, but if I go here to my network, I can normally download a VPN script, and I can say it's for this or this or this device. So this is the device that I configured, the 550. You specify your settings, and then you get your script, and it's like that. And it's much better than it was in the past, because in the past all these values you had to replace them yourself, and that was, let's say, my nightmare. Now it seems pretty nice. And then locally, this is the script that I had to execute on my Cisco. Okay? If I would have a Juniper, it would be the same, a different script, but same concept. And for the Windows server, it would also be, I think it's PowerShell one for that one. Okay, so where you set up your VPN from the cloud. You can also, but you cannot do that on a running network, but you can create point-to-site connectivity, and that's the one that I talked about. For that, you need to have the security. So how do I allow someone to get access to my point-to-site network? That's with certificates. So you created a trusted, root certificate provider, and anyone who wants to get access to the to this network needs to have a certificate locally that is being assigned and provided by that authority. So that's the way of going. Last time I checked, it's not possible to revoke, specific certificates. Like, you're no longer working in a company, so you don't get access to our thing anymore. So that's something that is probably maybe already there, or at least being worked upon. This is what I said. It's pay while it's running. So it's not the cheapest thing, the gateway configuration. So even if you're not connected, as long as your gateway exists, and that's actually the way you reserve your public network, your public IP address, as long as that one is existing, you pay for it. And if you want to make changes through the portal, it's not always easy. For example, you would need to delete your gateway and have to recreate the gateway, meaning you get a new IP address and you have to update your local Cisco device. That's not what you want. If you want to make changes, you should use PowerShell, because then you can keep your, let's say, existing IP addresses. Static and dynamic routing, where dynamic is in a preview. Okay? So that was the first part of the talk, unless someone has questions on the virtual networking. No. So the first part on different settings and different ways of connecting local systems, devices, applications with the cloud. The next part will be about BizTalk Services. So BizTalk Services is generally available since, I think, end of November. And it took them quite some time to go there. So, and the good thing is that we've been working more than almost 3 years with that team, and I'm guessing that we will be continuing to work with them, to improve the service. These are all of the reasons why Microsoft wanted to go and start BizTalk Services. Who has been working with BizTalk Server before? That's a lot. Okay. Who hasn't? Okay. So the concepts of BizTalk Server, because it's the first time I'm presenting BizTalk Services to people who haven't really worked with it. So BizTalk Server, yeah, it's a lot of the things that you have seen with Service Bus from a messaging point of view, where you have messages coming in, you can distribute them one-to-many pub/sub and all of that. But there's things that come with it. For example, you can get flat files, transform them to XML, disassemble them to XML. The XML can be mapped, so that's transformation. That result can then be delivered again to something else. You have workflow, which is not workflow, but it's orchestration. So it's not the workflow that we know from SharePoint or workflow.net. And the good thing is also that you have a lot of adapters. So adapters, if you want to send from FTP to mainframe, if you want to send from SQL Server to web services, so that's all with adapters. But inside the box, it's always messages coming in, going out, and you transform them. The concepts or the reasons why you use it is typically EAI, so that's Enterprise Application Integration. That's connecting data between different systems inside the network. And B2B. B2B is the part where you have business to business, so the different business partners connected with each other, sending invoices, sending orders, and so on. Okay? That's about as far as I will go with the intro on BizTalk Server. A lot of the concepts will become clear in the demos. We know these things from Windows Azure platform, and this is the one that was added, so integration, the BizTalk Services thing. On the BizTalk Summit was also announced that they will add workflow as a service. And that's the BPM thing they are looking at. They have also acquired, I think it was called Epiphany or something, for API management. So that's also linked with these things. Of course, we have been talking about the messaging with Service Bus. So all of those concepts will get back and will be visible in BizTalk Services. So the different things you can do with it, it's hybrid application. So it's all about hybrid stuff. You have things running in the cloud and you want to connect in a secure way to your on-prem things. We have seen it in the past hour. That's relay service, that's Service Bus, all of these things. And they use the same technologies, right? They wrap it in a new service. You also have BizTalk Server running locally, and you can connect easily from services to server, and you can do that direct. Think about relay binding, a synchronous call, or queued through Service Bus topics or queues. It's config driven, you will see that. So you have a bridge designer where you can do all of these things. You have a transformation, so a mapper, and you have a nice partner portal, which I believe is very helpful, especially if you have been working with a trading partner in BizTalk Services server. It's a managed service like most of the things, so you don't have to care about the servers. Microsoft is, installing them, is upgrading them, so it's really as a service. You can't even log on, so you don't have RDP capabilities to your servers. Although they are dedicated for you, you don't control them. So that's something that you can consider as a pro because it's managed service. It's not of my problems. It can also be a disadvantage because sometimes you want to have maybe the detailed look into it. So that's up to you to decide there. No, it's a total new thing. So the end longer term vision, and that's not, let's say, 2014, is to have one unified platform that will be similar in cloud and local.
It's not like every additional piece of
No. So the transformation engine is totally different. The routing engine is different. So there's no. And one of the typical things you heard with BizTalk Server was, oh, there's a SQL behind the scenes, and all the messages have to go through that box, and you have persistence. In I think more than 90% of the cases where we use BizTalk, that's a plus, because you really want to have that durability for retry and so on. But here it's totally different. There's no SQL behind the scenes. No. It's extensible, and if there's one thing that I have been, let's say, asking for constantly, was that they have to have extensibility. If you have done integration, and actually if you have built projects, you know that standards are there to be abused by different customers. So XML with a flat file string in front, we have seen it. Yeah, it happens all the time. Bytes, characters suddenly appearing in JSON strings, whatever. You need to be able to tweak that, and it needs to work, right? And it doesn't always have to be through the standards. So that's why custom extensibility is important. And that's in bridges. You have APIs, and you can use a tracking. So we will see more on that. And one of the reasons that there was no extensibility, like no custom code possible in the beginning, was that they were looking into a high density platform, a multi-tenant thing, compared with Service Bus, where maybe my messages are in the same SQL backend as your messages, but we cannot do anything with it. It's just running in parallel. Here, if I want to have custom code, the only way that Microsoft was able, at least that team was able to do it, was by providing dedicated virtual machines. So I have my own virtual machine, which is good, and maybe it of course has an effect on the pricing level that they have set. Okay. Maybe they should look into something like Azure websites, where you can have custom code pretty much on the same boxes, but that's probably a different isolation level there. And then you have the security, it's mediation, it's all cloud-based, so you have the scale and all of these things. This is one of the scenarios that we see often, that we see coming up, where customers sometimes have BizTalk server locally to connect to their mainframe, whatever they have there. If they have, for example, production systems, not all customers want to have their connectivity, their synchronization of production and warehouse, for example, through the cloud. They want to have it as independent as possible. If their internet connectivity is out, production should keep on running, right? But other things that are, for example, already going through the cloud, EDI. So they receive orders, they receive invoices or send it out. That's going through the cloud anyway nowadays, through the different big parties. So there we see customers looking into, let's say, all the B2B will be received in the cloud, and we will have one secure link internally to our existing ESB, to our existing bus. Why? We have a customer that it takes 2 or 3 days to build this interface, but it takes him 1 to 2 weeks to set up the connection with their business partner. They need to open a firewall, so that's a security form that is executed in America. It's executed by the time that they are sleeping here, so you know it's not working, and it always takes some days to get that up and running. So to speed up the process, what they want to have, they want to receive everything in the cloud, where there's no corporate firewall before, and from there they want to have one secure link. So receive data here and securely send it in one stable link, and that should speed up the process much faster. Other scenarios where we see Service Bus combined with BizTalk services, mobility, and BizTalk server locally. So you have a lot of technologies that you can combine based on your different scenarios. Okay? So let's talk a little bit about concepts. You can see this is a Microsoft slide because it's full of animations. So the different concepts, it all starts with, on the left you have the tools that you work with. So you have a portal where you can log on to, and everything you can do in the portal, you can do through PowerShell, right? And a lot of things you can also do with Visual Studio. So Visual Studio is your development environment, so there you can create your bridges and deploy and so on. Then you have TPM, that's Trading Partner Management. So you can manage your partners, create agreements, profiles, and all of that. The bridges, if you know BizTalk Server, compare bridges with pipelines. So it's a way of receiving a message, acting on the message, and routing it to a specific endpoint. You have them for in different, how do you call it, patterns, an XML, one-way, an EDI, and a pass-through. So you have a two-way XML. The XML one-way can also support flat files, but XML two-way doesn't support flat files. So sometimes they still work. And the artifacts, so you can deploy certificates, you can deploy your assemblies, so custom code and so on. You can deploy your schemas, so XML schemas, and your mappings. And the result, you have tracking, config, and monitoring. So that's all in SQL. So the tracking, for example, is in the SQL Azure database, and it's like a documented schema that you can get access to. So you have your connection string. If you want to build or get data from it, you can build tooling on top of that. And they also have a storage account where they write all the logs to, just like you have with cloud services. So the diagnostics tables and so on, they are also filled from the servers there. So you can write from your custom code logging that will end up in those tables. Okay? So how do you configure things? You need to go to the portal, and there you have BizTalk Services. You can say I create a new BizTalk service. You give it a name again, so it's like your namespace. Then you select your edition. So you have basic, developer, premium, and standard. And this is also a little bit new compared to most of the other services that we know. So every different service has different limitations. For example, in a basic, you can only have 15 bridges. In a premium, you can go to 500, right? But you can scale a basic to 2 units, meaning you would have 100, for example. Eh? But this is much different from what we have seen with other services, and it's maybe not what you really would like or what you expect from a real cloud service, where we are used to say, okay, if I don't send any message today, I'm not paying for anything. If I send 1,000 messages per day, I pay for that. Maybe I want to shut down my servers at night and so on. This is a little bit different and is not there, I hope, yet. You can, for example, not stop your service. You can delete it, unless it has been changed since go live. In the past, you could only delete it, and then you don't pay for it, and you have to recreate it, but of course, you lose the settings. So it's not a pay-as-you-go thing. What's very important, it was not possible to do EDI in the past with basic or standard. Now they have brought EDI in every single unit, which is very important. The prices are here. No. On top? Here. Yeah. So if you look, this is per hour, but in reality, you have to look into the per month. And again, you will see that it's a premium service compared to, for example, Service Bus is unless if you send tons of messages, but this is much more expensive. Again, if you compare with BizTalk Server as we know it, from today, running locally, this is in some cases cheaper. If you look at the basic ones, for example, in the premium, you will end up with a higher cost over time. Okay, so it's a monthly fee. You need to think about. You need to look at it like that. Okay. So this is the one that counts. This is just the preview price that is kept until the end of the year. Okay. Again, like everything, you'd say, I want to deploy it to one of these data centers, and then you can say, I create or use an existing tracking database. On the database, you can specify the server, for example, run it here. You give it a username, and let's create a new one. I forgot the username. You can set specific things like who should have access and so on. You can write your your diagnostics accounts. Let's create a new one. Als ik demo diagnostics. And then it will take 30 minutes. In reality, it's less. So it's again creating a new virtual machine for you, creating the database, setting up all those things, and that takes, let's say, quite some minutes. If you have played with it in the preview, you see that the experience is much, became much better. In the past, you had to upload your own certificates that had to be signed, and you had to have all the storage, the service bus credentials and so on, looked up and so on. This is now all automated. But this is one that has been created already in the past. So here I have my service bus namespace, and you can see I cannot do too much in this portal. So I have a dashboard where I can see the number of messages and so on. I can do some basic monitoring, and then I can do the scalability. So this is a dev edition, which means I cannot scale. If it would be basic, I could scale up to 2. If it's premium, I could scale up to a lot. Again, you pay for a lot then. But if you want to really do the management and have access to the real, let's say, configuration portal, it's in a separate thing. So it's in portal.biztalk.net. And you have to log on with your Live ID or a Microsoft account or organizational account. Anyway, and there you can configure a lot of things. For example, here we have the partners. That's for the B2B part, and I'm coming to there. You have the bridges, you have resources, you have tracking and so on, you have general settings. So that's the portal that you get access to. And I'm diving in the details shortly, okay? But that's the way you set up BizTalk service. So the trading partner management, that's the B2B part. And who of you has played with EDI in the past? So Edifacts, things like that, X12. That's what you can set up here. Edifact is coming soon, and it's still coming soon. We expect January, February maybe, depending on whenever they release it. You have As2 support, if you're familiar with that. Actually, that's a protocol over HTTP with certificates and NUX. So if I send an invoice to a customer over HTTP As2, I have to sign it and encrypt it. They send back an MDN. What is that? It's like a hash of the data that they have received from me, and they sign it, and I can save that MDN, that requests or that response. I can save that in my own database, and it's legally binding. So if the customer later says, no, I have, or you have ordered 1,000 instead of 900, I can say, no, you have approved, you have acknowledged that I have sent this specific message on that time, and you send me a hash for that message. So it's a legally binding thing, and that's also supported, the As2 protocol there, but it's very specific to EDI. So in the portal, I will dive to it, and then you can route incoming messages. So if you get messages from your customers, from As2, for example, an invoice, you can route it to web service, to blob, to bridges, and to service bus and things. Okay? So what I have here, I have two partners, enterprise and customer. And every partner has one or more profiles. In reality, most of them have one. And then you can specify qualifiers. So I'm not planning to spend too much time on this one, because if you don't know EDI, this doesn't make too much sense. If you know it, we can definitely... Exactly. EDI sense, right? But you have qualifiers, the way they can detect settings, and the important one is here that you can have agreements. So here, for example, I have an agreement between enterprise and customer, and that's the one where it should make at least some sense. So where you have the hosted partner and the guest partner. So here I say the enterprise is the hosted partner and customer is the guest partner. You can specify if you want to have tracking of send and receive sites. And then, of course, you have the details. So receiving messages, if I receive messages from that one customer, how will they be handled? And here you can specify the protocol. So here I say, for example, they will be received over HTTP. And in that case, the customer has to send their messages to that endpoint. You have other tests. You can say they should be received over FTP or SFTP. It's very common still. Those are not the modern, RESTful, whatever you want to have. No, a lot of customers still have FTP, SFTP, and we need to support that. And then the AS2 one. Right? So for that, you need to have the agreements. For FTP, you can see it changes based on the settings, right? You can also promote some properties. So if you think back about my service bus messaging thing, the properties that I extracted, flight, carrier, and all of these things, you can extract them here from the protocol. So I could say I will promote HTTP or SOAP headers, right? And they would be added to the message. So I could do pub/sub on that later. Then you have the protocol, and the protocol is different from the transport. The protocol is really the handling of the EDI, and this is where it won't make too much sense anymore. So where the most important one is that you can specify the different document types that customer is allowed to send. So in this case, they can send a purchase order. If I would add an invoice, they could, also send it. If there's no agreement with the right ones, the message will be denied. So you can upload new schemas. You have all these settings that you know from BizTalk, or that you don't know, but you have them also here. Then transformation. You can upload transformation. So on the incoming message, you could say, I will transform it to the document format of my XML web service and so on. And in the end, you will route them. Here, I'm routing them over relay to this endpoint. If something fails, for example, the endpoint is not there, they will do a backup transport to this endpoint. And yeah, they should maybe hide that key. What you can have is, you can have multiple routing settings. So again, and this is what we know from the service bus thing. Here you could say, if, there's probably one here. If the message type equals border, for example, you should route it to that queue. If it's something else, you should route it there. So here you specify the filters in this nice portal. So let's escape that one. And then you can say, okay, apply and deploy, and then the agreement is valid. Not going to spend too much time on this EDI thing. I will just show the demo. So remember that I had the agreement here. Okay. On the receive side, where I said in this location, so I will send from my test tool an EDI message to that location, and it should end up where? It should end up here in a relay binding on that endpoint. Okay. If I would send the other way around, then you have the same things. So me sending to that customer, I can send to HTTP, I can do transformation, and the only thing that is new here is batching. That's also historically, in the past, customers had modems to dial in and send EDI. That's why EDI is so compact. And sometimes they had to batch it. So they said every 10 messages should be sent together, because making a connection costs money. You were not connected. The modem had to be dialing in, and I have sat at customers where I could hear the modem doing, to send data to their partners. It's not that long ago. Anyway, what I'll be doing here is on my demo, using my test tool, and I will be sending to the receive. So you can see, actually, these are some kind of test cases, and I pre-populate my configuration settings. So I will send this message. So this is what an EDI message looks like. It's an X12. So this is an order, and people know what to do with that. Really? And you send it here, okay? I'm sending it on that namespace and so on. So what I will do, and by the way, I had to remember that I had my relay. If the message was received over HTTP, it would be routed to my relay endpoint. And that's what I'll be starting here. So this is a console app just exposing an endpoint again on service bus. I showed in the beginning of my talk my local cloud connector, exposing a management web service. Here I'm just exposing a service from this cloud application, from this console application. And if I submit here, you can see that the message was received with all the context. Of course, it's not very easy to read. If you want to have the details, you can see at 2018 we have received the message. So the message of EDI has been translated into an XML message, right? And that's the way every message that comes in will be translated to XML, because there you can work with it. What about JSON? No support yet. It's on the midterm roadmap. Okay. So far the EDI. Always happy when that part is done. The next thing is EAI, and that's where you have more, where you work more with the messages that really come in. Again, it's config driven, so we'll dive into that. But then a concept that it's important to know is a bridge. So a bridge is actually an itinerary where you have one or more sources. You can then have the pipeline to treat the message, and then you have one or more destinations. Let's go to Visual Studio, because that will make things much clearer. Oh yeah, TFS09. So if I create a new service, I'll do the demo. So it's just installing the SDK. It doesn't come with a web platform installer, so it's a separate download. But then you have your toolbox and your canvas. So here I have my itinerary, and I can, use these things here. So I can say I will be reading from an FTP. Then I have a bridge, and I will be sending it maybe to another FTP location and to maybe a service bus queue or a blob. So this is the different artifacts you can use. And of course, you have then a connectivity where you can say, okay, this FTP source should be linked with this one from here to there, and from here to there. So my message will be picked up here. It will be processed by this bridge. It will be routed to there or there. I said or, it's never ends. So it's always, and I will get back to that, it's always the first match subscription. Getting back to this, the first thing is the bridge. So in a bridge, you can have different stages. So here you specify your schemas. I'm expecting this or this or this type of message. If it's a flat file schema, you can support it, so I will show that in a minute. Then you can enable validation. So if the incoming message has to be validated against a schema, this will happen there. If you don't want that, you should just say is enabled as false. Then you can enrich. Enriching is actually getting these from inside your incoming message and add them to your context so that you can route and track on those messages. For example, you can say, I will get data from the incoming SOAP headers or from the HTTP headers. What you also can do, you can do a lookup. So you can do a lookup in the SQL Azure database. For example, the order number coming in. Maybe you want to do a lookup to see if that order exists or if that order is maybe for France or for Germany. That could be in a lookup table. So you can configure that here so that the incoming message gets looked up in SQL Azure, and the value, the result of that query gets promoted. XPath expressions, if you know XML, you know that you can have a specific query to an XPath, and that value can be extracted to the context again. Same things with FTP. If you want to get the file name and do subscriptions or the server address, the folder name, you can use them for routing. And you have some system properties here. So that's the stage of the enrichment. Then you have the transformations, getting back to that. And after the transformation, because the transformation is changing data from schema A to schema B. After that, on schema B, because here the message just flows through that, on schema B you can do enrichment again. And in the end, if it would be a flat file schema, it would be encoded there. So, oh boy. Here I have some solutions ready normally. I wouldn't call it a workflow, but it's indeed, no, the canvas, the itinerary, there's no workflow behind, but the pipeline is actually a customized thing of XAML workflow, but you cannot have custom shapes and things like that, so it's not, allez, close it. So the first one here, is this one. So this is what I wanted to show with the routing. Let's try to zoom a little bit. And I would not really consider this even a workflow. This is more of a message flow. So your message can be picked up by a FTP. It can be processed by a bridge order. So here we can have extraction of properties. Maybe it's a big order, it's a small order. Then it will be routed to one of those, and again to the bridge, and in the end it will end up in one of these endpoints. So to explain a routing pattern, if you see here, a message will be routed to one of these links. How do you specify that? That's in the routing table. So if I zoom here, you can see, and maybe you cannot see. So you can see that if the quantity is larger than 1,000, it will be routed to endpoint with discount. If it's smaller or equal than 1,000, it will be routed to the pass-through. This, of course, is it's mutually exclusive, so it can never meet both filter conditions. But imagine that it would be if quantity is larger than 1,000, and here we have country is Belgium, and I would have an order of 2,000 for Belgium, then again it will not be routed like we have with service bus topics. It will not be routed one to many. It will only be routed to the first matching. So if the first matches, the other filters or the other checks are not done. So that's totally different from what we know with BizTalk. And that's also a disadvantage. So sometimes you want to have one to many, sometimes you want to have one to one like here, or first match. Oops. And that's not supported yet. So what do we say? Oh, you just need to send to a topic, and of course then you poll on different subscriptions. It's possible, but it will come again early next year. It's not possible to poll on queues or subscriptions with this thing, and that's of course something that we really need if you want to have durable one-to-many messaging. That's something you need. So all of this routing end-to-end from here to there is all done in memory. That's why you might have seen it was very fast. But I want to have persistence in a lot of cases. And if my order comes in and my backend service is down, just persist it, and I will retry it, for example, as an admin. My end user here sending my order, he doesn't have to know that I have issues there. I want to receive it, and I want to continue to process it afterwards. So this is the total opposite from what we know with BizTalk. With BizTalk, you could not do anything else than persist. Here with BizTalk services, you cannot persist unless if you use topics under the scenes. Okay? So what I would love to see here is just a check that says durable, and magically they would use a topic or a queue behind. Maybe it will come. So that's the concept of the whole routing thing. Let's switch back to here. The extensibility points that I talked about, you have 3 ways of doing that. First of all, you can create custom code in the pipeline stages. So it's writing a custom message inspector. And if you know that, you think back about Wcf, but it's a different kind. It's a lightweighter one. It's an easier one to write. Also in the transformations, you can write, and it's always a funny name if you don't know BizTalk, functoids, custom functoids. So a functoid, it's like a function, but they call it not a function, but a functoid. It's things that you can drag in your mapper. I will show it any minute. So you can write custom code to do specific things, and you can add them into your mapping. And then on the destinations, you can have custom destinations using Wcf bindings. So for a message inspector, it's not the cleanest solution yet, but actually, at least we have a solution. So it's just a matter of implementing this interface iMessage inspector. And then you can have, of course, you need configuration a lot of times. I talked about the PDF signer that we want to use. There I need to have the certificates location, who is on blob. Maybe I want to have the reason of the signature and so on. So these are properties that I want to configure outside of my components. So for that, you need to tag them and attribute them with a pipeline property attribute, and you give them a name. And they have to be public. They have to be string. So integers, not possible, for example. They have to be string, for whatever the reason. If you want to have, you need to do the casting yourself. And then there's one method, which is pretty similar to the one that we know in BizTalk pipeline components. It's an execute one. You get a message, and you get the context of the call where you can do things with. The difference is that you need to return a task. So to get it executed async, what you can do, you can also write to the diagnostics table. So I talked about that. You have a storage account. You saw me creating one. So they will be written. If you use context.tracer, you can write events from your custom code. And of course, you can do, you can change data. You can do, you can access the message body and all of these things. So, as I said, only string properties. Write things. You can do property promotion, so you can promote custom properties like this, message.promote name value, and the content can be accessed. It's as a stream, and if you know BizTalk, you know that it's all about streams there. What's new, and I believe that not a lot of people will have seen this because it's brand new, is that you can debug bridges using the Server Explorer. So if you look in the Visual Studio Gallery, there's a new tool or new add-in or plugin, and there you can manage your BizTalk services from within Visual Studio. So that was not possible in the past. For example, it was not possible to stop and start an FTP endpoint. You had to write PowerShell for that. With this plugin, they made it possible, so that's a very nice one. I hope it comes into the portal sometime. Let's see if we have somewhere. For example, this one, FTP orders has been stopped. I can now start and stop and so on. So you just register your things here, okay? If I now go back to my custom code, I will show you what I created, and then I will show how I can debug the pipeline. So if we go here, for example, here. Here I have this bridge where I receive, and you can see it's a two-way bridge. So I receive data coming in, and I can do logic here. It will be routed below here to the destination, and the destination has to be two-way because the response will be processed through this pipeline again. You can see I have two messages, and I call them binary dots because you cannot send binary, like PDF is binary. You cannot send it, so I wrap them in an XML thing with base 64 and all of that. And then I do my custom code, and that's what I wanted to show. So somewhere here, and that's also something that I would prefer to see better from a usability point of view, somewhere on one of these stages, I will have custom code configured. A little icon would help me, but it's here. So here I can see that I have my custom code executed where? On exit. So if the message leaves the stage, so if all of this has happened, transformation, validation, and whatever, at the end, at this point, my custom code will be executed. And how do I do that? By copy pasting the full, the full assembly path. It cannot browse, for example, so they really need to invest in these things. I have my properties. If you know BizTalk, you have a nice property grid where you can set all the configurations. Here you need to do copy paste, so you need to say property name equals this, property name 2 equals the other value. So the things, location, that's the one that, this one, for example, pipeline property, that's the name that I'll be using here. Okay? So whenever I deploy that, it's pretty easy to do. You deploy from Visual Studio. It seems I have a validation thing, so I will not deploy. It's still deployed there, so it should work. So it has been deployed here. If you look into the, what's it called? Signed PDF bridge. Someone sees, here. So this bridge will now be called with my tool. So if I click here PDF, what you can see, I have this sample, just a very basic PDF. You can see the signature, there's no signature. I will upload it and I will push it to this endpoint. So this is just an HTTP endpoint. I will publish it, push it there. Did I click it? No. And you can see a very nice 500 error. So that's just to show how we can do tracking. So I can do a refresh here, or I can go to the portal. So getting back to the portal here, you can also see the tracking. And let's find out what could be causing the issue. So here we can see on exit message pipeline expector. So I have an issue there. Let's click in the details. We can see something, failed to add certificate, error while loading certificate from blob, blah, 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 blah. So probably something in my code went wrong. I'm not planning to debug this one. But you can see this is the way you can do tracking from the cloud and back. Let's try it one more time. I swear it worked. Yeah, anyway. So that should be the custom code execution there. It has to work with demos. So that's custom code. Then the mapper is something that I really need to show. And I think... So this, for example, is the mapper. And of course, this is a very simple, very straightforward mapping back items from one to the other. This is a functoid. This is, for example, to do the sum of the quantity and add it to the total quantity. So functoids, you have quite a lot of them. You can even do, unless they are not here anymore. In the past, we could do a sinus and a cosinus and a tangent and all of that. Never used it, but So you can do a lot of things. You can add items to a list. You can generate date times. So that's all custom code that is executed and packaged, and you can wrap it in your mapping. So you can see it's if you have used the BizTalk mapper, it's again a nice enhancement. There's a big difference behind the scenes. BizTalk was using XSLT, which is a standard for declarative mapping transformations from XML to XML. Now they are no longer doing that. Why? At this point, it's only XML supported, but in future they plan to have object-to-object mappings with that. They plan to have JSON to object or JSON to XML, whatever. So they plan to make this more of a generic mapper type that might be outside of BizTalk services available. And that last thing is not something that I have heard or something. But looking into that, it makes sense to have it in workflow, for example. So that's the mapper thing. Of course, one of the questions that comes up with BizTalk customers is, yeah, but what happens with our existing maps that we have built? And we have these thousands of maps in our team foundation. There's two options. You can just take the XSLT from the maps, because the old BizTalk maps are XSLT based. And if you click here, you can specify and just upload your XSLT. XSLT is still supported, but if you don't do it, the mapper in memory, custom will be used. And there's also some tools to map or to convert your maps to the new schemas. If you want to know more, we have a nice blog post by Glenn that you can read from it, and maybe it's a good suggestion for the BizTalk user group to give a mapper session one day. Thanks. So if you want to learn more about the mapper, go Glenn. Because to be honest, we most of the time use XSLT because it's something you need to learn, but whenever you know it, it's much faster and it's cleaner to work with. So that was the mapping thing. Now, the next thing is, no. What I want to show here was the new thing. So we have a Service Bus Explorer, and you can now debug, and that was not possible in the past. So you can step through the different stages of your pipeline. So how does that work? You need to register a service bus relay thing, and if you say I want to debug the bridge, all the events are published to your Visual Studio on the fly. So it's a nice concept that I'll be showing. So if I pick in the Server Explorer one of the things here, let me think about. No. I will take this one for after my next demo, because otherwise I would have to show my next demo already. So I'll go back to the debug things shortly. So the custom Wcf bindings, that's what I have shown here, where you can say, okay, this one, for example, can be just a web service endpoint, but as you know, that's WCF behind the scenes, and there you can customize custom bindings. So in this case, what I have done, I used the echo binding. That's just an SDK sample, and the only thing it does, it gets the request and it just gives the request back as a message. It's to do a loop back. I don't want to go outside of my service. If I just want to sign a PDF here, I don't need to go to an on-prem thing, so I just loop back my message, and that's with a custom binding. Where can you also use custom bindings? Maybe you want to go to Salesforce or CRM and you need to add custom authentication headers and so on. So you could create a custom binding and just easily upload it to these things. A custom functoid, it's an easy thing to write. And then a PDF thing I have shown. And this is where I really want to come to. It's connecting from the cloud to your local ERP systems. So if there's one thing that BizTalk was pretty good at, and is pretty good at, it's the adapter thing that they have. If you want to connect with SAP, there's an adapter. Oracle applications, adapter. Web services, adapter. POP3, whatever. Mainframe, there's an adapter, right? And they want to have the same concepts. So what they have, and it's similar to the thing that we have built and that I shown, the connector, you can install a BizTalk adapter service. It's also locally in IIS, and this is exposing just an endpoint over relay. So whenever you call, it gets relayed through IIS, and the existing adapters that we know from BizTalk, SAP, Oracle database, Oracle applications, SQL, and Sql, they are still available in the box. So you could connect to these systems. And I will show how that goes. And again, they have a management service that you can talk to from PowerShell or Visual Studio. At this point, it's not extensible. In the future, tomorrow, but tomorrow is like philosophically tomorrow, they will no longer have the SQL database locally with the adapter service. They will have support for custom LOB sources. So now you cannot poll on SQL or SAP. You can just use it as a destination. You will get better diagnostics, more line of business systems added. It will be extensible to add your own systems. It should be a better experience, although I have to say the experience is pretty good. And they will also foresee more high availability on the client side. So what I will now show, and it's not there, is how do I connect to SAP and SQL from the cloud with BizTalk services. So what I have logic where I say I have customers in my SQL database, and that's the EMEA customers, so all the customers from Europe, Middle East, and Africa. And I have my customers from US, I have them in SAP. For example, I have just bought a company in America, and I didn't consolidate the ERP systems. Could be a typical case. But still, I want to provide a service to get customer details. Give me all the customers starting with A, for example. And based on the region, I will connect data to SAP, or I can connect to SQL Server. So how do we do that? I will switch to my empty thing here, create a new project. For example, I say, okay, let's start by a request reply bridge. By the way, what I didn't mention is a bridge on itself has an HTTP endpoint. So you don't have to have HTTP and so on. You can call a bridge directly on an HTTP endpoint. So that's important to know. But on this bridge, that's one thing. But of course, I want to route my message now to my SAP or my SQL database. So what I do for that, I use this one here. So I have this talk, and maybe I should zoom a little bit. Here I have my BizTalk adapter service, and you can see there's 5 adapter types. In this case, I have used SAP and SQL. If I want to create a new one, for example, I just say add SQL target, and I have to specify the settings of my database. Let's see. Why not Flight Radar? I use my Windows credentials, hostname. Okay, maybe this one will work. Yep. And then you can specify, okay, I want to call store procedures, or maybe I want to do take aircraft, for example. I do a next. How do I connect at runtime to this thing? I can specify my user. Next. And then this one here, specify the LOB relay URL. So this is, the first thing was really getting local data, but here I say, how do I expose that data to the public? And that's using relay. So I can say create a new relay binding, and I enter my settings for the namespace and my path in the namespace, okay? Or I can just say no. Select one that I have already, like Sql, and then I can give it a subpath. For example, Azure flights. And on this endpoint here, whenever I start my local thing, I have a public addressable web service where people can call my table, okay? Of course, you need to have the right credentials, so you need to have an ACS token and things like that. So if I click next here, I finish the wizard, then you can see that I have my targets here. What I can then do, just drag it here, boom, and I can go and connect toolbox. I can connect and I can say every message that enters here should be routed to my local system. That's all. Of course, you need to specify the schemas. So schemas, how do you do that? It's just right-click, add schemas to BizTalk Services. So what happens now? He will ask SQL Server, how does your table look? And he generates a schema, an XML schema that represents that table. So you should be able to see it here. Aircraft. So if I, for example, would want to insert data into that database, I need to create a schema, an instance of a schema with these fields. I will send it to that local system, to that local service. So no, I will send it to the public bridge that I have there, and that bridge would then route it further to my local database. Okay, it would be inserted there. Now switch back to the real existing demo, because there's quite some more things you need to do, some detailed tweakings. And that's this one here. So what I have, as a scenario I talked about, I have a public endpoint here. If you call this endpoint, I will route to one of these destinations to another bridge, and then I will route it to either SAP if it's EMEA or SQL if it's a US request. So how do I do that? First of all, I have a schema. The schema looks just like this. You specify a region, so EU or US, a name and a number. Then I do a validation. I think I do an enrich here. What do? I extract the XPath from the incoming message. So this large XPath, I extract and I promote it to the customer name and to the region. I say, okay, the region has to be EU or something. I don't do any transformations here, but what I do is the routing. So here, if you click on the routing table, you will see that if the region is EMEA, then route it to the EMEA customer. If it's US, route it to the US customer. Okay, what do we do here? Here we do the transformation. So here I have, because what I accepted, as you can see, this thing is my friendly, nicely documented schema that is called by the clients. But of course I need to map to the LOB schema, the schema of that SAP or the schema of that so here I'm going to SAP. So what I will do, I will map it to SAP. And if you go and have a look in the SAP schema, this is nice, right? German abbreviations. How do you see they are German? They are in capitals. No, this is a typical, oath name. But But this is not something you want to expose to your clients. This is something you want to shield from them. Also because if SAP changes, you don't want to have your clients updated. And that's what you do. You decouple here SAP from your local. And here we have the other one where we map to SQL. So as you can see, we have a stored procedure that accepts customer name and number. So we call the stored procedure on SQL, exposed as a service, and we get back the data. On the return, we have the same thing. So we map the response to our friendly response. So this is the response we get back, and we map it to a customer list like this. Okay? So that's the logic. This is deployed. And if I want to test, I should be able to do that with this one. No. Here, SQL and SAP. So I have 3 different schemas, or 3 different test messages. AB, that's everything that starts with AB. All the customers will be returned. And that was, no, I should look here. All the EMEA customers starting with AB. And where do they come from? The EMEA customers come from, I forgot it, SAP. So let's have a look at where is my SAP. Actually, my SAP is here. 2 gigabytes of RAM. So that's all that SAP needs. Go and tell that to the CIOs. And a designer, yeah. How did I end up here? That's probably by entering transaction something. You can see it here, SE37. That's how you end up here. You just have to know it. So here I have a list of customers that I can do a query on. So again, how do I move out here? Yeah. So that's what I will do. I will call my SAP system. So if I here go back to my test application, all the EMEA customers, I do a submit. Now he does a call to my bridge, to my SAP system, and back. And that's 1.7 seconds. Doing it again is 200 milliseconds. So this is not that slow if you compare that with what we have seen in the past. If you compare that it's actually going to the cloud and back. And the service itself is pretty scalable. The throughput is not that bad, especially if you consider that the validation happens, that you do transformation, you do routing. So it's pretty good. So this is the EMEA ones. If you now do a list, maybe I should open the message. So these are the customers starting with AB, right? If you now do all the customers with A, so that's a larger list. It will take a little bit more time, but if you do and have a view, you can see it's a pretty large message in less than a second. So I have to say performance it's very okay. And of course, if you now want to go to SQL Server, and you don't believe me, so I think I have the customer table here. So the customer has to start with, no, it was the US one. So the customer has to start with AB. So let's create a new one. AB Azure. Okay. Count again. Okay, so we should see AB Azure or Azure in it. And if we open it, there it is on top. I was looking in the bottom, but I think I do an order by name or something. So you can see that the data was retrieved again around a second to get the data. from the cloud to my local database and back, without writing any line of code except for my store procedure. But that's yeah, that's something that's pretty useful in my opinion. The thing I wanted to get back to was the new one. That's this test thing that comes with server. So what I can do, customer get, I can, for example, say send test message, and here I can just load a message. So the things that we could not do in the past, just testing bridges, we can easily do it here. And if I now go customer get, that's the one. I can also do a debug. And here you can do a step through and see how the message changes from stage to stage. And how does that go? I need to specify some settings here. So I created a namespace, a service bus namespace. And I have to specify these credentials here. And then on the fly, Visual Studio is creating an endpoint, a relay endpoint, where the cloud service is sending all the events to. And I can follow that up here. So I should be able to say debug. To load my message. Where's the message here? So I'm loading my XML message as an input. I say all the US customers from AB, and I can say send message. And now you can see step by step that he's actually stopping in the cloud and he's sending back the message as it is in the pipeline at that stage with the context. If I do a next, continue, you can see, for example, that these credentials here have been updated. So customer name has been extracted, US. For example, here we have the query that was, you see the message body has been updated, right? We enrich some properties and so on. So that's really the thing where you can do pipelines. You can see, oh, did my custom code really did what he had to do? Was the message property promoted that I wanted to have, and so on. They are not able yet. They will, or they are looking into have code through, step through of your custom code, so that you can really attach to that. But that's not not here yet.
Is it possible to select these select stages, but you don't have a pickup for every stage if you just want to test at the last stage?
No, not at this point. This is still alpha version, new. It's not a supported thing, so they release it, they will enhance it. It's not part of the SDK, so it's part of the Visual Studio Gallery. And it's the very first stages. It has some bugs. For example, if there's a property that is not a string, it will have an issue. So it's really the first one, but the concepts are nice again. And maybe it's a feature that we can easily ask. What you can do, for example, is some stages you can disable them, right? Validate, disable, and then you will not see them. But good question. Okay. I think with that we can wrap up. I hope you enjoyed it. So with WAPs, with BizTalk Services, I believe it's at this point good for B2B scenarios, especially because B2B is going to the cloud anyway. You can do, it's very well supported. The partner management is good, except for IDIFACT that has to come. Also some pipeline capabilities as a service. Extensibility is important. They listen, but they have to improve a lot of things, and especially around configuration and tracking and the whole usability. I believe that there needs to be quite some improvement there. And the last one, the durable pops up, preferably just configurable by a click of the mouse. That's something that I would really love to see there. With that, I think it's more than time enough now. So I'd like to thank you. And if you have questions, of course, don't hesitate to contact me. Thank you.